Hello everyone, today I will be going to discuss another topic which is about continuity and discontinuity. Continuity test. A function f is continuous at c if the following three conditions are satisfied. So first, f of c is defined. Second, limit of f of x where x approaches to c exists. 3. Limit of f of x where x approaches to c is equal to f of x. So if f is not continuous at c, it is discontinuous there. So we have here types of discontinuity. So first is the jump discontinuity. The left and right-handed limits aren't equal. Then, the double-handed limit does not exist. So we have here a graph. So as you can see in the graph, it is discontinuous at 2 because the limits are not equal. Therefore, it does not exist. So in the graph, we can see here that the graph is not connected to each other. Second type of discontinuity is the essential discontinuity. It occurs when the curve has a vertical asymptote. This is also called as indefinite discontinuity. So the graph is essentially discontinuous because there is a vertical asymptote, so as defined in the definition of essential discontinuity. So we can say that the graph is essential discontinuity when there is a vertical asymptote there, just like the graph here. Another type of discontinuity is the removable discontinuity. So it occurs when you have a rational expression with a common factors in a numerator and denominator because these factors can be cancelled. The discontinuity is removable. So as you can see in the graph, there are two graphs in one frame, and it is also called as removable discontinuity. So we can say that this is a removable discontinuity because of a common factors in both numerator and denominator of a function. So now let's test the following equation. Test if f of x is equal to x squared plus 2x plus 1 is continuous at x is equal to 0. So first, let's test if f of z is defined. So in our example, x squared plus 2x plus 1 is defined because we have an answer of 1. So next, let's find out if our limit of f of x where x approaches to 0 exists. So in our example, x squared plus 2x plus 1, our limit of f of x where x is 0 exists because the value is 1. So in number 3, let's find out if our limit of f of x where x approaches to 0 is equal to our f of z. So the value of our limit of f of x where x approaches to 0 and is 1, and our value of f of c, or the f of 0, is 1. Therefore, the function x squared plus 2x plus 1 is continuous at x is equal to 0. So let's test another example. Determine if the following functions are continuous at f of x is equal to 2 over x plus 1 at x is equal to 0. So in this example, we will find out if our function 2 over x plus 1 exists. Is continuous if our x is 0. So number 1, let's find out if our f of c is defined. So 2 over x plus 1, to find out if our f of c is defined, let's just substitute the value of 0 to x. So we have here 2 over 0 plus 1, which has the value of 2. So therefore, our f of c is defined. So in number 2, let's find out if our limit of f of x as x approaches to c, or the 0 exists. So the function 2 over x plus 1 exists because we have the value of 2. So in number 3, so in conclusion, our f of c is equal to limit of f of x as x approaches to 0 because they has the same value. So our function 2 over x plus 1 is continuous. So that's all, and thank you.